What did I do yesterday? I think I just used yesterday as a reading day. Yeah. Yeah, I did. Yesterday I had to read a lot because I have to join a fucking book thing tomorrow. Wednesday. So that and then probably watched some D&D. But that's fine. I'm still doing even if I'm only doing let's say I'm only doing 3 hours a day. It's still 21 hours a week, but it's really more than that. So okie doke. So let me quickly find out what the fuck this video is about. What was I doing? String stuff? Oh, more string. More strings. Cute. Cute. Okay. Fuck. I don't remember where I was. I do remember there being some string viewage though. So that we don't have to copy my value everywhere. We can just. It's not a reference either. I guess it's passing. Instead of it copying it to a variable, it is. I'm not really sure how it works just yet. See how far I've got. Okay, maybe. Oh, yep, definitely didn't. Hmm, haven't seen that either. Haven't done this either. Nope. Oh, fuck it. Start from scratch. Okay. Okie dokie. Hmm. Yeah, instead of just using it. Here, we're taking this literal string, literal C style string. And it's a C style string just because it's a regular. Yeah, it's just a regular literal string, which means it's C style. We're copying a C style, which is inefficient, into this guy to initialize S. We're then printing S, meaning we're taking S and then we're copying it to str in print string, and then we're printing it. So we're copying it, copying it twice just to print it once. So it sounds like whatever we're doing, whenever we only need read only access to a variable, we only give other variables read access to it, at least for a string. So we pass a string view instead of a string, instead of a standard string. In this case, we're initializing a string view, and then we're printing it. Okay? So we're passing it. But instead of a copy, hmm. So it's initialized, but with only read-only access. So it gets the value, but I'm not super sure how this is different from a pointer. Haven't learned that yet technically, so let me not think about that yet. Okay. Provides read-only access. So if we use str, it seems like we're accessing the memory of S. Okay. Hmm. Okay. Need input. That we want that last. So we're initializing one from a C style string, literal. Cool. Yep. Okay. So I'm gonna make a function this time, and we're just gonna have a variable. So we'll just do. No, well, I don't need that. It's fine. Oh, so it doesn't. I'm surprised it didn't care that we haven't been using this yet. Hmm. Okay, yeah, we'll accept everything. So string views. So how does that work? Does that mean, I think it still means I would need to take the string view and put it into the function. So put the string view in my argument, or in my parameter, or yeah, my argument. Because I think otherwise it's copying the value to it. Maybe it's not though. Can be initialized with a bunch of shit, which is cool. And things will be converted. Okay. So it will be implicitly converted. Yeah. Oh, because we can't. So what does it just prevent it from being copied? Hmm. See what happens if we do that then. So if we take a copy of a string view and we pass it by value, if I had a standard string variable and then made a string view and it was initialized as that string variable, and then I passed that to be a string, I get that it might have an issue because it can't copy the value of the string view. Alright, well, let's see. So we need string first. Hmm. Can't convert string view to standard string. And it's because string requires some sort of value to be copied to it. But if this was string view, it wouldn't have any issues because this is a variable and this is passing read only access instead of copying it, and string views can't be copied variables. Okay. Well, is that right? Well, then what if I did but no issue here. So this can be initialized, but what if we do really? So that part's fine. But I was using copy assignment just now. That's copy assignment. Where I'm taking a string and I'm copying the value from a string view into that string. But then it says it can't be converted. But isn't that what that's doing? So if we said that this was instead integer 1 and this is float 1, we say integer 1 gets float 1, and this is integer, this is float. See? So it has an issue here. Excuse me. So we are implicitly converting here a float to an int. But before, bro, oh. But before, isn't this the same shit? And it seems like it to me. So we can initialize a string with a string view. We can explicitly cast a string view to a string too. So we can explicitly convert a type. We can initialize with it. But can't we even copy assign with it? It seems like we can. We just can't pass it to a function where that conversion is done. Seems like. This is all just a baseline. I don't need to go freaking absolute micro figure out exactly why, because once at the end, if I still have some of these questions, then I'll work it out. Assignment changes what the string view is viewing. Okay. Okay. We have a string. We have a string view assigned that string. And then we take the string view to be assigned another string. Well, instead, that string now views this other guy. So it views. So a string view views a string. And the problem is that a string view, so a string view can be assigned with some shit, but can a string be assigned the string view? It feels like it can, because in list initialization, we're initializing it. So we're initializing it with the value of the string that the string view is viewing. At first, the string view is viewing a literal. So it's actually viewing the literal. Is it different if I do this? Because then the string view isn't... No, no different. So the string view is viewing a garbage value. The string can get that garbage value. But we can't pass the string view itself. So the point is that assignment is getting what the string view is viewing. But when we're actually calling a function and passing it by value, that is different than the assignment's usual pass by value. So I guess... Okay. This is terrible. No, bro. Come on. This is terrible. Bro. Oh, I know this one. Okay. Ah, it is now viewing John. But it hasn't been assigned the value of John. And then we print John. So it seems like John is still stored somewhere. He isn't created and lost. He's created and kept in purgatory? Maybe? Well, yeah, it wouldn't have mattered anyway because name holds that. So even if these were integers, it would still be fine. It's just that instead of SV being an integer that's holding a value, it's instead just viewing something. That's passing the value that's viewing, I guess. Literals. Excuse me. Type string view suffix. Okay. Default C string, default standard string, default string view. String literals and string view literals. I thought I needed the literals. Oops. So it doesn't actually care if we don't use strings, seems like. Yeah, it makes sense. Well, yeah, because it's watching that value. So, hmm. Well, yeah, they are in disguise because if I initialize a string view with a string view, that string view literal is actually a temporary string view that's watching a temporary string. That actually seems like the least optimal way, but it's actually still okay because we have a literal and we're only viewing it and viewing that. We aren't actually copying that, viewing that. We're just viewing. So we're viewing the viewer. Holy. Alright, I thought we could. Oh, oh. Oh, oops. Cool. Because this is a string view that is viewing a literal string view. When you create a literal string view, you have a literal, there's this literal text that's stored somewhere, and then you have another, some temporary storage area, and you have another temporary storage area that's a string view, and it is watching that, it is viewing that, and then I've explicitly created X, which is a string view which views that. So views the view, boom. I think that's how that means. Which is why it's in disguise. Const expression string view. I don't remember why string and const expression don't work. Oh, it's because strings aren't C style strings are not. Well, could be const. If I had a const string... No. So, const expressions can only have const expressions inside them. Well, but literals are, so it sounds like literals might be okay. Let's see, I don't remember. We need to test this. We don't even need output, we just need string. Oops. Okay, so we can have a const string. Uh-oh. And that's because strings, I think it's only certain types of literals. I think string literals are not constant by definition. They're not constant expressions. And that's because maybe because they're acquired by the string header. Oh, this is good. Wait, Fonk is solid. I like this. Oh wait, there was one that, like this that I liked a lot. It's an error. It's because it's not even supported yet. I guess it didn't matter. Yeah, see, like things like that don't matter. Oh, here it is. That's good. Oh, of course, but string views have full support. Okay. And that's because they're viewing stuff and it's unchangeable, so the viewing... Oh, it's because they're constant by definition. They can't... Well, they could change, but you could make them constant because the values inside them are not changeable by changing it. So, let's see. I guess you just wouldn't be able to reassign it, so I could do const expression, and that's fine. Oh, symbolic constants are... Okay. Oh, symbolic constants are the opposite of non-symbolic? Unsymbolic? I don't know. They're just identified. Identified constants. Okay. Bro. Bro. What? Bro, nobody's asking for this. Oh my god, I don't have input. That's why. I'm so fucking stupid. Alright, so if the autocorrect doesn't work, it's because I haven't included it. That's why. Okay. Excuse me. Oh, that was good. Cool. Makes sense. Because it's constant. That operator doesn't match. Bo. So you're just asking, are you gonna get get a reference to something, or have something that it has to be this because, well, you're creating variable, but this is a reference to that versus something that's watching that. So I don't know. Oh, the reference because it's just binding a reference. Hmm. Okay. So string views. Okay, that makes sense. All right. Yeah. Don't focus too hard on the details. Just keep going. Part 2. Okay. We good? Hmm. Oh, instead of so string view, if it's watching a bike and looking at a bike, you got a picture of a bike. Then you take a picture of a different bike. You don't have to fucking worry. You just let your previous picture go to the wind. You don't have to go and manually destroy it and be careful with it. Hmm. That makes sense. So if I need to get access to this string, I don't copy it to another variable and then dispose of that variable. Instead, I just look at it with this variable. Like copying a reference that I'm not able to touch, seems like. True. Hmm. Yeah, exactly. Which is why I was saying if it's constant. Hmm. Yeah, you'd have to feed the constant expression string literal. Oh, that's why you can do that. Okay. So if you fed the constant expression string literal, or string view, sorry, string view, a string variable, those can't be, uh, so those, when constant, they're not integral values, so it's not a constant integral value. It's not a constant integral variable. It doesn't work. It's just a constant non-integral variable, which does not work for constant expression. But a literal string, when you have a string view, we know we can't change that literal, so we're good to go. Nor can we edit it from our own, but it doesn't matter. Okay. General string views, yeah. The reference could change, but that's the same. I mean, it's the same anyway. It's basically a constant reference, it feels like. Hmm. Oh, because the variable changes or gets destroyed. Oh, that's good. Yeah, this is good. I'm doing like 10 push ups real quick. Oof. All my legs are tired. I need to figure out a better way to sit. Oh, it's still hard. Hey. Oh, I think I'm gonna have some stomach pain here. Because I had a better version of Takis and milk and pizza with bacon and hot honey on it. Oh, fuck. Oh, I ate a lot. I'm full. It was half a pizza and it was a lot of milk. Like 3 glasses that were like more than 8 ounces a piece, probably. Or about, probably. And my right foot's asleep. Fuck. Powering through it. Okay, we're good. Oh, it's asleep. It's a soul owner. Ah. Okay. Yeah, it's a soul owner because sure, there's a bucket, but I'm taking all the things in that bucket out and making copies of them. Like I'm taking that bike out of his garage, putting it next to mine, and creating a copy of the thing and putting it in my garage, which is really hard. And then I'm putting that bike back. I never really took it from the bike or from the garage. It's basically like I created another garage right next to his. Saw this bike and I was like, ah, made another bike. And then here they are. And the garage wasn't even used before, so. But my garage owns it. My string owns the shit that's in there, which could be good or could be bad because I get control, but I also have used up a bunch of space instead of just looking at it. So, like, if I take a picture of my buddy's garage and his bike, I don't have a new garage and bike. I don't have to have the storage to store them or the space. Alright, I'm doing a quick song because I can do Osu for like a minute, so it's fine. I'm gonna do that every little while. I'll do one song. Alright, wait, where's the... Was I doing 2 stars or 1 star? Dude, I swear it was... Oh, we're doing only... Okay. Alright, we're doing this one. Colors are still not muscle memory at all. I hate it. Oh yes, let's go. I'm doing one more. The rule's 2 songs.
next time.
Cool. Oh. Yeah, once I have a picture painted of the bike outside, I don't need to see the bike outside anymore. Hmm. Hmm. Yeah, true. Yeah, like if initializing something is a void function that has some parameters that I'm passing some arguments to, after I pass it to it, it's a void function, yo. It doesn't pass anything back. It doesn't say, hey, here's a reference to the shit that I made. Here's my bike. No, dude. That's not it. It's like I threw a picture of my bike to the guy. I have no control of what he does with the picture. Yeah, duh. Oh, well, actually, vice versa. So the caller sends me, the guy sends me the picture of the bike. Okay, I build a bike from the picture. I can't touch his bike that I took a picture of. Oh, I have to pee or something. My stomach feels full. Oh, compared to standard string, which does still look at it. It's like, if he sent me the picture, but the picture was tied to his bike, sure, I can use it to make my own bike. Well, actually, no, I'm not even using it to make my own bike. I'm actually just using his. And let's just say I put it on Craigslist. And then if he changes his bike, but when I go to actually sell it and use his bike, well, the bike's different now. The string variables can be dangerous. String views can be dangerous whenever. It seems like you'd almost want to use const string view or use string view and then not use it anymore instead of keeping it, because the variable it's looking at could change and maybe it's likely to change. I don't know. Oh, this is hard. Makes sense. Yeah, it owns its information. It owns the information that I use when I use the variable. I owned a bike. My buddy asks me to let him ride the bike. He can ride my bike. If I have a picture of my buddy's bike, my other buddy might be able to use that. I, the program, might be able to use me, this string view, to access this other shit. But if my buddy sells his bike, and then my other buddy comes and says, "Hey, can I ride your buddy's bike? Where's the bike?" I'll say, "Yo, I ain't got a bike, bro. He sold it." So we don't always need a copy. Sometimes we could just do a string view, huh? Oh, this is one where we have a string, initializing it from a C string, literal. But then we're copying the value into this other string that we're printing. Instead of just doing string view. We could do this a couple ways. So we could say, this is a string view, and then the implicit conversion happens here, bop bop, or could static cast here and then leave this, but then it's just one extra variable. Oh, excuse me. Oh, what is this? This is the one I know. We all know this. Here it comes. Yeah, everybody knows that one. I figured. Oh, my stomach, dude. It is full. Yeah, I guess I'm not hungry. That's right. Yeah. Yeah. Hmm. Oh, so the problem is, could it be just so? What if there's some parallel shit going on? Because in here, the logic is sequential. So we start one line and we relinquish control. So this variable that exists over here can't. Like, it's like my buddy takes a pic of his bike and his bike is then in purgatory. Well, it's like if he lets me use his bike. I'm using your bike, bro. I can't. Your bike's fine. Your bike can't be destroyed by somebody else if I'm using your bike. So in here, we relinquish control here, and we're here. So nothing is executing here, so nothing can happen to this guy. But if it could, if this kept executing while this is executing, that could be bad. Could be modified. Same thing, destroyed or modified. You could have just said modified. Oh, this is about to be hard. I know this. Never listened to this stuff explicitly before. It's only ever in fucking stupid YouTube shorts at work or something. No, it does not. Yeah, true. So he's not gonna be destroyed or modified. Hmm. And if we need to modify them, then we'll do them as a regular string. Get a copy. If we don't need to modify them, it's fine. Okay. It's an owner versus string view is a viewer. View of the string. Hmm. Yeah. But if the viewers, well, the view. But if the thing being viewed is destroyed, then the view gets fucked up. If the bike's gone, and I'm using a live stream, not a picture, then my live stream gets fucked up. Cool. Yeah. Mm-hmm. A dangling view, because we're viewing and it's gone already. Hmm. Well, yeah, it makes sense. Oh, this is okay. Always purple. Why? Oh, yeah, read-only function parameter. So a function that is looking at something and just needs to see that value. Makes sense. Without having to make the copy. Yeah, yeah. So we need to output something as a function, but don't pass it the whole fucking string. Just pass it a string, or just give it a string view. Uh-oh. Yeah, I don't need to see that reference, buddy. Yeah, passed by const I value? I don't know what that is. So, two options here. Are you passing a string view to a string view or passing the string to the string view? I think the second one here is redundant. You don't need to make a string view of a string and then view that because it's the same result. It's actually less efficient because you're creating an extra thing to watch it instead of just watching it. Yeah. Yeah, we pass any of them without making a copy. Yeah, you wouldn't want to do the string view. They just do a string. And it wouldn't matter what happens or how long print SV is. Because by the end of it, that's when we get control back. That's when main gets control. Go to the bathroom real quick. Oh, and my stomach, dude. I am maximum full. It's just full of food. Well, and water too. I should probably chill in the water maybe. Oh. Turning the fan off. It's cold. Oh. Oh. Everything. Man, I'm getting bloated up, dude. Oh, I can't even flex it. Oh. See how heavy I am right now. I'm curious real quick. Oh. 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 Ooh. Oh. I'm full of pounds of food. Oh, 157 right now, dude. We are thick, thick. Oh, I've been closer to like 153 or 154. This is all just food today, not water weight. Oh, I'm leaning back now. This is good. Right. Okay. Most case. Oh, okay. That was over the reference. Okay. This is just a pain, and it's similar. Yeah. Improperly. Why is this improper? Okay. So we create a string view, and then I don't know what the fuck is happening here. What? There's just a, you can just do a nested block of code. Okay. Oh, well, yeah. Well, yeah. What? So yeah, you can access anything in global scope in smaller parentheses. You just can't access things in these local scopes outside of them. So accessible here. Inaccessible. Well, so we're pointing this guy to this guy, which means sure we can use this guy, we can print him, but this guy doesn't exist. So who the fuck knows what he's gonna print? Oh, good. Yeah, why would you do this? Why would you do this? I don't know why I had some. That was crazy. That's how to generate spit in my throat apparently. Hmm. Sorry. Okay. Okay. So we have a view called name. And name is initialized as a value that's returned by a local. We can't watch a local, yo. We need to copy. We need a copy of him, dude, because he's been destroyed. Right, this guy here, created, returned, copied. Well, would be copied, but starts watching. Destroyed. Watching him, but he was destroyed. Yeah. Like, hello? Use him here or copy him, but he ain't getting copied. Yup. Dangling. Let's see. Well, yeah, because it's temporary. We're watching a temporary. Same thing would happen here if this is just a straight literal. What? Okay. So only when it's a standard string, I guess, is the bad part. Because if you do a string view, but wouldn't a string view be dangling too? Because if that was a string view, then it's watching the literal. And we're watching the literal. Oh, but the point is that the literal doesn't go away? I'm not super sure. I'm not sure why it's okay to do those. C style is okay, and a string view is okay. And the reason that's okay. Oh, I remember. It's because C style strings are alive for the lifetime of the program. And that's why we're not supposed to be using them. Because if we keep using them, we are unable to. We'd have to figure out where they were temporarily created to kill them. Well, I guess they're not even temporary if they're lifetime. 15 push-ups. Let me get the speed up. Hold on. Here it comes. Oh, I thought it was gonna speed up. Alright, well after this one. Oh. Wait, the bouncing's actually good. I forgot I can totally read while doing this. That makes sense. So it's totally fine to do string view because a string view is watching a C style when you create him. So the C style is created, but he's alive for the lifetime, so it's okay. But we don't know where that string is technically. Oh, I forget. I can stand. I don't have to sit the whole time. And sometimes I want to, but the standing will make the sitting less monotonous, I guess. Once I get a good thing, I'm gonna do some push-ups because I feel like it. I need to chill too because it's gonna get cold. It's gonna get hot. Oh, so much food, so much volume. Oh, it was all the milk. I haven't drank that much milk in a while. Again, same one? this. Okay. It's okay. Oh. Oh. Okay. That's okay. That's fine. Yeah, because the C style object does not outlive the other. Or C style outlives, but the standard literal does not. So C style literals are good. Shit, can I do push-ups that fast? If it does it again, I'm doing it. Oh shit. Oh, I can't. No, I can't go all. I can't go full range of motion. I don't like doing push-ups without full range. Oh, this is the song. Well, yeah, it makes sense. I mean, we have Hello World, but then we change him, but then we print SV. So he's viewing S. Oh. Oh wait. Modifying S. He gets this value. Copied from a temporary C-style object. C-style string. Temporary object. This guy watches him. But if we change him, it then invalidates him? Why does it invalidate SV? You'd think it would... I thought it would update. When a standard string is modified, any views are likely to be invalidated. Oh no. So do not modify him. I thought only the destroyed part would be the important one in those three considerations earlier. Is it going to be destroyed, modified, or modified in our use somehow? Or does it need to be modified in our use? Turns out the modified one's actually really important. Because if it gets modified, this motherfucker's invalid. I had no clue. Really? What does it say? So we need string view, and string. Need output. So we need a standard string variable. Excuse me. Yo, yo. Alright, we'll just do string one. Excuse me. SE1. And he uses T as string one. And then we do str1. And we'll just assign him yo, yo. Str1. But then so it's undefined, so it should be okay. Yeah, I mean, it's fine. But maybe on some compilers. But yeah, because it's subject to the implementation. Alright, push it down. Okay. When it's modified, likely to be about. Yeah. Okay. If it reallocates memory in order to. Oh. I forgot that we learned that standard string reallocates memory. So if it gets longer, then maybe the string view was looking at the wrong type of memory, which invalidates it. Maybe. Let's do a test. See if I can get it without looking. Oops. Fuck. So we need a string again. Ah, fuck. We need fuck, can't copy, whatever. Oops. No semicolon. Oops. The fuck happened up there? What am I missing? Oh, there's the bracket. Yo? Oh, oops. Oh, what the fuck am I doing, dude? I was cooked after the push-ups. My brain. That is why. And now what if we do? Oh wait, we're good. Oh wait. Views that. But then we reassign that. But then we print them again? What? Okay, that's undefined. It's not reflecting the change. But if we make him tiny, but then we do a bunch, issue. Why? Smaller memory, bigger memory. 43, 5. So 42 plus no character. We had to allocate more memory here, which means this guy was viewing something of smaller memory, and now it's larger memory, and we haven't told him to restart the viewing. So if we said, so we did that, issue, but if we then said SV1, like that, then maybe we're cool. We're cool again because the view gets reset. Okay, makes sense to me. I will take it. It's because we're reallocating memory. Oh, because it reallocates, because it's like here, and then we're reassigning it, so it gets this new shit and then frees the old shit. It doesn't dynamically say, I need this much more. Oh, take it back. It says, I need this instead. Take that back. It's like a kid with a toy. Gets a little toy, and then once it finds a big toy, it tosses this one. It doesn't only take what it needs. Like, you give a kid little Legos, and you give big Legos. He's probably gonna throw the little Legos and take the big one, and not take the big ones and put them on top. Which would technically be wrong in this case, it'd be too much. But it's fine. And now it just still works, mostly. Stomach's getting better. Yeah. Yeah, because when we reallocate the data, it tosses away the old shit. So even though it's just a size change, there's actually more going on under the hood. It's getting more memory and throwing away the old shit. It's like it's expanding the bucket, kind of. I wonder if it's a different location. Probably not, right? The address shouldn't. Maybe. If it reallocates, does it change where the memory is? I don't know. Feels like it because allocating, instantiating is the process by which an object is allocated memory, or at least an identifier is allocated, or yeah, an object. So an object is given memory. The bucket is given a size. It's given a radius. Does not. It will copy the new string data over the old string data, which is why it's on. Well, which is why there are different results. Makes sense. Oh. Oh yeah, if it was small and bigger, it might have an issue. Yep. Makes sense. The bucket's this big, and he's looking at that, but then if we shorten it, and he still pulls this out, he's gonna get a bunch of garbage. But if it's big, and he's looking at this, and we shorten it, we get undefined behavior. It didn't fail to compile, it just was getting all this extra shit here. And since it's reading binary, binary plus binary plus binary, it doesn't look like cool plus extra shit. It just looks like, eh. Well, this was the push-up song. The beat is very, very strong. Yep. Excuse me. Invalidate meaning fuck up, not render any compiler errors or anything. Revalidating. Well, yeah. Yeah, because you're just making him point to the right bucket again. So you're saying, hey, bucket, look at it. Look at it. Bigger. Issue. Looking at the wrong shit. Look at it. Then we're good. You have to make him look at it again. Man, this one goes hard. This shit is really good. Holy crap. Look at a pretty lady for a sec. Let me get an annoying lady off the screen. Alright, now we're good. Oh shit. Looking at that lady. Alright, I'm good now. Oh, be careful just because it might not be in scope. Like if we're in, pretend this is another function. You know, returning this guy, we're returning a view to some guy, but we don't have him in scope down in main. Revalidate it. Yeah, because we're just reassigning it the bucket so it gets sized properly. I'm gonna do a back fixing exercise really quick. And do some extensions on the floor real fast. It's kind of hard to fit, but need to take these off. Glass is getting fixed soon. Oh, my stomach. Oh, it hurts. Oh, my stomach starts to get hurt so bad. Oh my god, it hurts really bad. Ah. 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 No. Oh, it hurts so bad. Come on. Ah. 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 Oh my god. Oh, it hurts. Forgot the camera was fucked up. Oops. Oh. 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 This. Dude. It sounded like a grumbling at the beginning. That right there. That sounded like grumbling. Alright. What am I, some streamer repeating myself? Jesus. Alright, let me see how the volume is. Okay. Excuse me. Yeah, just reassigning him to get the size right again. So we're looking at the right bucket. My buddy gets a new bike. I make sure, hey buddy, what bike did you get again? Before I go and tell people what bike he has. I don't just tell him. Instead, what I'm telling people is a mismatch between what he actually has and what I'm saying. But rather, there's a mismatch between what I'm saying and what he actually has. But local variables that are created within one, if I'm returning a string view, well, I'm probably returning a view to a local variable, which if it's gone, ain't no good. Yeah. Yep. Let's see what happens if I do that. Oh, it's probably just gonna be garbage values. We need string. Yeah, sure. And it probably won't. It'll probably still compile. It should. I don't see why it wouldn't. Do I even want to do anything? Oh, so I'm just gonna do. Just kind of output. Yeah, whatever print thing. That's fine. No, we're gonna do return. No, not return. Standard string view is the return type. It's called print thing. Has no parameters. What it does is it creates a standard string called called string 1, and it says this is string 1. Yo. And then makes a string view called string view 1, and it's initialized string 1 so that it looks at string 1 basically. And then we are returning string view. No compiler error. Cool. But it's probably gonna be garbage. Uh-oh. I think that's the value for like the space between memory or something like that. Let's just do it again. What happens if we'll try this, see what happens. I mean, it did it for every character, so yeah, what if we do less? Oh no, just chance. Just chance. Okay. I mean, that was cool. What are the odds that we got something that looked like that? That was nice. Oh. Alright, I'm gonna do 2 OC songs real quick. How far away to the end? Damn! Just keeps fucking going. String views are cool. Okay. I mean, I'm learning. A lot of it's just... most of it is, they're examples I've already known. Wait, this is a really cool sounding song. Oh, I know this. Fuck! Alright, I'm playing it. I really shouldn't do this, is too hard. What I should do is actually find a better difficulty. Yes! Nice! This song is great. Hard for me to lock in, man. I like the songs too much. I like the drumming. Fuck! I was going way too fast. I'm doing it again. Yeah. Please God erase us.
things further complicate. So if it all fails, just throw it back in my face. I can take another complication. Have mercy, please, God, erase us. I can take another complication. Have mercy, please, God, erase us. Every day I wake up to stagnant bullshit. As soon as I escape, there's more stagnant bullshit. This endless propaganda, corporate agenda. I like to think there's more. I'll tell you what I worried about it. I hope you won't be saddened while I cry about it. So if it all fails, just throw it back in my face. I'm locked in this place, it's such a waste. I can't watch things further complicate. Have mercy, please, God, erase us. Have mercy, please, God, erase us. I can't take another complication. Have mercy, please, God, erase us. Have mercy, please, God, erase us. Please, God, erase us. I can't take another complication. I can take another complication. Have mercy, please, God, erase us. I can take another complication. Have mercy, please, God, erase us. Erase. I can take another complication. Have mercy, please, God, erase us.
Easy, baby. Almost SS too. I got like one fuck up, the tiniest. Minus one. Oh shit, my rankle. Hey, look at me, dude. I'm doing one more, man. This song is just fucking hard. Fuck. Difficulty. I'm doing one more because I'm just in the game mood, and I'm allowed. I don't care. But I mean, I do care. I want to get better at coding. I want to just not, but I'm greedy. Oh fuck, we need to do days. Oh, this song is so good. Good and happy. Whatever, I don't care. Planning to get better and to have fun. Alright. They can be revalidated by setting it back to a known good state. Yeah, makes sense. Makes sense. Yeah, we've already seen this. Cool. Alright. Be careful. Yeah, because we could return some bullshit. Yeah. It's local. It doesn't exist anymore. Yeah, yeah. Oh wait, what is this? Oh, hold on. Yeah, yeah, yeah. Okay, so what's happening here? So we're saying get name true. Oh, we're returning a string view, and we have true and false. Oh, if B. So if it's true, return what? So it's supposed to be true and then false. But instead, it's nothing because those strings were created upon definition and then destroyed on the last curly bracket brace. Yeah. I was like, this code is weird, bro. Yeah. Yeah. Yeah, it doesn't work. Not now. And the issue here is because these are strings. These are standard strings. These are C-style strings, which means they're temporary objects, but they live for the whole program. So it's actually okay, even though these are done locally. They're created in what feels like global scope. Yeah, so we're saying we're outputting get name true. Okay. So then get name, passing him true. And then if he's true, return true. If he's false, return false. Okay. So, but these are C-style string literals. So it's actually okay for us to return these. And even though these are string views that are viewing these values, these temporary objects, it's actually okay because they're still alive and haven't been touched and can't be touched because they're string literals. Temporary object, and I don't know where he is, but there's probably a way you can get the location of what a string view is viewing. So yep, yep. It's okay to return a function parameter. Oh, I don't even know if I've ever done that. Well, yeah, I've never passed something to something and then returned the thing that came back. But I guess one way you could do it is like sorting something, like giving it to something and then returning them, but in a different order. Or yeah, like passing it so it'd be a parameter, but then returning it, but returning it to another function or something. Never done that. The point is because there's a view, these are strings, I'm passing of string views, and these are viewing this, and then I'm returning these guys. So I'm returning. Yeah, but these guys are created and they should be destroyed here. If I'm returning a string view, then these are views into views that are viewing real guys. So I guess it's okay. Maybe, since we're looking at the same thing. But if I'm a sniper who's sniping and I'm sniping at a sniper who's sniping at a thing, if I'm I'm looking at a mirror. It's looking at a car. It's okay. But if someone kills the mirror, then I can't see the car. Unless I can, somehow. Okay. It may be less obvious why this is okay. My guesses are, so there's a C-style and a C-style. Oh, so I think that's probably the answer. So we're passing variables that have these values. Boom, boom. These are views that are looking at these values. We are returning, and so in this, so it has views in here that are looking at those values, so it doesn't have to copy these. And then we're returning them. So we're returning one of them, and it's here. And it seems like we're returning it. This here is a temporary string view that is a different object than these. And it looks like it's pointing in that direction. So it's like there's a mirror pointing towards something, and I give someone else a mirror that's pointing towards that thing that's pointing towards that thing. But then when we get rid of the middle mirror, if this one is still looking at the thing, we're okay. Oh, ow! A and B exist in the scope of the caller. When it's called, S1 is a view into A, S2 is a view into B. When it returns S1 or S2, it's returning a view into A or B. Since they exist, it's okay. Okay. So I'm returning a string view. I'm not returning this guy. I'm returning a string view. So normally it's, if this was an int and this is an int, I'm not returning this guy. I'm returning an int that has his value. But in this case, I'm returning a string view that has his value, which doesn't mean it's been copied. It actually just means that he's been looking the same way. So I'm giving somebody a mirror that is facing the same direction as another mirror. So I'm saying, hey, my mirror is pointing over here. Here's a mirror that's pointing that way too. And then I can destroy my mirror. But because your mirror is looking that way already, we're golden. If an argument is temporary, that is destroyed at the end of the expression contained in the call, Oh, the point is, it's okay to be used immediately here, because even if this was bad, like if it was an int and whatever and something was funky here after, this works and it returns this value here. So first, this is okay. It's been returned and then destroyed. So it can be used here. But after, nope. Cannot be used later. So like if we set a variable equal to that, then this part's cool, but if it's used here, then okay. But if we're actually initializing a variable, well, it's the return, so maybe, yeah, it's okay actually, because it's been used immediately, so. Okay, let's test this. So we need string view. We need input output. We need... I just want... What do I want? Print that. I need a fan. Got hot. Oh. Man, that stomach is tight, dude. Okay, return string view. We're returning. It's called my string view. The parameters are none for now. It is creating a string called just string. Yeah, we can't copy them, so we gotta do string view 1. Okay. Oh, so that's not okay. Well, we'll do two things actually. Oh. What? Oh, I didn't fucking... What? Bro. Why was it cool with that? Okay. Uh-oh. Oh. So we have a string. We have a string view that is viewing him, and then we're returning him. Just gonna test. But then when I remove it, huh. Oh, well, the problem is it's been returned. Well, yeah, shouldn't it be returned here? And then it goes away? Oh, but we're returning a string view into... Well, but this should be a literal, so this should be still maybe that. I'm gonna test another one. How about... Or no. Standard string view. We'll just call it. Yeah. Oh, so it's not even doing the whole thing. All right, it's too cold now. So this guy's initialized to be that size. So what if I did this? It should have a conversion issue, right? Yeah. Yeah, we can't convert. What if it did? Oh wait. I can't do that. I can't return the static cast of a thing because I can't return the... Well... No, because it doesn't have an identifier here yet. It doesn't know it's being returned yet. Actually, I'm curious here. This is string one, huh? Wait, what is happening here? Oh, because this is a view. So the sizes get kind of wonk. Okay. Alright, it's too hot again. Oh! Nah. Yeah. Just keep some wind going. So if we store it, the problem is it's a string view, but if we store it straight away, then even if I return a string view, this should still, wait, hold on. Fuck. Wait, what? What are you fucking talking about? Hold on. Oh, because this is the implicit conversion. Oh, shit. Alright, so we're returning a view. Turning a view to him. Oh, well, that's going to be kind of whack anyway, I think. So there's a string called string one. There's a view that's looking at it. We're returning that view. But that means this view would be looking at a view, and that's no good. But if we do that... Oh, that's okay, actually. We can return the string view into the string. Oh, there's... Okay, it is different values each time. Good. So we're returning a string view, but string views don't get copied, so... I don't even know what happens here. But if we return... What if we return the string? And then we just say we return... It's okay, because we stored him straight away. But the viewing doesn't work. So here... This guy exists, then we're cool. Alright. View modification functions. Ooh. Instead of output modification, like what? Set bool alpha. Set precision. Or is it even set bool alpha? I think it's just bool alpha. Yeah, it is. Oh, excuse me. Oh, I threw up just a tiny bit. Fuck. Oh. Set precision. Set. Oh. Standard character input to white space, so that we can get the whole line of text. Oh, still some shit there. Alright, third time around, I'm getting tired of this. And he only has good stuff. Wow. Alright, I'm not trying to hear all that. We'll just do... Oh, this is good. Oh, this is the best one! Dude, I used to listen to this before Organic Chemistry 2. Oh, I remember listening to this going to my freaking exam without really studying that night. Holy, or my final. Tried to go to sleep at the freaking honors college. Couldn't fall asleep because there's no AC and it was hot at night. Went to bed like, fucking walked my ass back 20 minutes and then went to bed for like 2-3 hours. Almost missed that exam. That was bad. I got like a B or a C or something. It was terrible. No studying. Ass. Oh, plastic bone. Fuck, man. Now I want to watch Breaking Bad. Damn, dude. How about this? I need some instrument. The perfect body. Just, no, wait. No, the neck is just crazy. God, like 25 more pounds, man. She'd be pretty. Excuse me, just healthier. Like health. Removes characters from the prefix suffix, really? What is the left side of the... Meaning, oh, and you say the amount, so one from the left, one from the right, really? Dot, remove prefix and suffix? Really? But, oh wait, how are we doing this? No, we're just doing that, okay. We need string view. We need IOStream for output. What? Okay. Alright, so we need... Excuse me. Okay. Okay, and now we need issue1 dot remove prefix 3. And then we'll do SU1 again. And then we'll do SU1. Okay, and then we'll do instead. But then instead of this, honestly, we'll just do still we'll just do it's easier. Bump. Oh, so we lose the first three, and then we lose the last three. That's cool. So it actually does just show you, here's this, we're looking at this, but then here we're looking at this, or here we're looking at this. This side, or this side, or both. Couldn't I technically... we fuck up both sides at the same time on the same line just to do it? I mean, technically, I guess we would just do, we would do it nicely. Like that. But, okay. We can do some suffix action. That's cool. What else? Alright, so we can do remove prefix or suffix. View a substring. Makes sense. Well, yeah. Isn't that what this is? Yeah, makes sense. Also, if I printed it and then printed something else. If I viewed the beginning, I wouldn't be viewing the terminated. And then if I printed something else, or if I extracted, it might be kind of whack. It might just continue. Cool. So this guy will just add it. I kind of want to exploit it really quick. So we need string. We need view. We also need output. Alright, so first, what do I want to do? So I want to extract to two separate things. I don't think it matters, but I'm gonna try something. Oh. Cool. Okay, good. Cool. Okay, so the point of this, we have a string. We have a view. Move some suffix from the view. Another string. Extracted a string. And then that should just output. Oh, wait, hold on. Oh, whoops. Well. Never mind, it didn't make sense. Well, first, I guess I'll just do. Oh, wait, hold on. So, string. So we're casting the string view to be him. Boom. Okay, cool. So that's fine. And then we could do. What if we just do. Need whites. So we need to do get lines so that we can do multiple words and shit. And then we need character input to not fuck up the leading white space, or to not, yeah, hold on. Yeah, to ignore any leading white spaces so they all get included together. Yeah, because without that, any end lines before would get included here. And then that's what this would extract. And then we're going to extract to string 1. Oops. We're going to just do string. Oh, actually we're going to do SV1. And then we're going to make a string view called SV1. And then he is string 1. And then we're going to do SV1. We're going to remove some suffix. Okay. And then we're going to print that B. This is a bad motherfucker. Bop. Cool. Works. Use a string when you need to actually use the boy. When you need to store some shit that the user can input, because we can't view. What would happen? What would happen if we extracted to a string view? I don't know. Yo? I typed it. Hmm. Uh-oh. Oh, you're not extracted to him. He's watching nothing. We just remove this. Then he'd be cool. Ah, it's because his parameters. He requires string. String. You need a string. Kate. Just say touched. Oh, a symbolic constant meaning something to watch it. Yeah, yeah. Identified constant. Hmm. Holy. Oh my. Oh. Yeah, it seems like usually you would just do this. Right? Yeah. And. Oh, instead of const? Or const expression? Hmm. You need to modify the string passed in as an argument without affecting the caller. Modify the string passed in as an argument. The string could be passed in. This could still work. Because the string view wouldn't affect the caller. I mean, you could do either, but... Why is it called this? Is this just a is this text? I value? Yeah, I don't know what an I value is. Is this too above my pay grade for now? Use a const string reference when It's older and it needs a read only. Oh, string view is new. Okay. Okay. Oh, so there's const and then there's regular. In and out print. Oh, who knows? God damn. Return types. Return type when it's a. Oh god. Here we go. Hmm. Do the string when you need him. Damn. Because if it returns a string view parameter, then the parameter you already passed, it's already viewing something that exists. Because the function can't kill it. But if it's C style, then it already exists. So return it when it's pointing or when it's viewing shit that exists still. Oh. Keep it const so you don't fuck them up. Basically just consistency. You have shit that depends on this, write this. You got shit that depends on this, do this. Okay. May. Is likely to. It's okay because we're destroying it because strings are move optimized or something, or move enhanced, move optimized. Hmm. Oh fuck, dude! I feel like I'm screwed. This feels hard. It's hard to learn though. Oh, const something gravity. Avoid using const when passing by value or returning by value. Meaning just because its value can't change? Returning a const something? If I return a constant, is there a point? Oh, it's already, isn't it already redundant because we already can't access it? I think it's redundancy. It's already ignored. Excuse me. We didn't know. Osu.
Welcome to us.
Dude, more of these keep appearing. I swear. Getting too scared of that last note.
See you next time.
Constant expressions are evaluated at compile time. Those that are not at runtime, yo. Could be calling. Oh, because... Oh, just because we're not setting the constant until runtime, maybe? Oh, fuck. That's why it's cold. Forgot. I'm staying up till midnight tonight. can. Dang. Okay. Cost expression variables must be compile time constants. I'll do this one I'm thinking, not when I'm reading. Function parameters can't because functions aren't called till runtime. Yeah, I guess so. F, S, SV. Yeah. Yeah, just set the constant somewhere. I don't like the term symbolic constant. I'd rather just say a constant variable. But excuse me. Ah, makes sense, yeah. Using an invalidated produces undefined behavior. It doesn't necessarily generate a compiler error. Why are constants often named constants than literal constants? You mean named constant versus a literal constant? Oh, you mean a literal meaning something directly inserted into the text, like quotation, whatever. Well, yeah, you'd rather have you'd rather have const name and then do that so that you know what it means, so that you can edit it in one place, so that your code is more readable. So what? It's for understanding. It's for power/efficiency, just doing more things at once. It feels like that's the main reason. Yeah. Yeah. Exactly. Why are constant better choice than define symbolic constants? Also, there's scope. So defined symbolic constants are available everywhere, which means that you run out of identifiers too, and it's hard to debug because the issues with the preprocessor directive debugging, I guess, has different stuff, and it's hard to understand sometimes. It's just not as known. There's scope concerns. Scope, usability, because the scope for defined is anywhere. It's at the top. It's known all the way to the bottom. Unless it's undefined, which we haven't even done before. Scope, usability, or so scope, debuggability slash known to work withness. Because I could do a preprocessor macro with substitution text, or an object like macro with substitution text, and have gravity and replace it with 3 and then just put gravity everywhere. Paint, it's not as easy to change. I don't even know if I can change it everywhere else. Do I just redefine it? I'm not sure. It seems like that's why. Yeah. More likely to have naming conflicts because of scope. And the constants do not show up in the debugger. Oh, because we can't watch it because they aren't variables too. Ah, yeah, that makes sense. Okay. Why are they a better choice? Because of scope concerns. So they're more like, I mean, they're used and seen everywhere. So I can have X in a function and another function. That's cool. But I can't define X and then do it again somewhere else. And the variables that we define, or the macros or whatever, I guess the variables, those symbolic constants. Yeah, they don't show up in the debugger. Okay. Find 3 issues in this code. So we do how old are you? And then we do an unsigned int 8. Oh, a couple things. So one, this is all one character. That's gonna be wrong because this, it's gonna add up all the integers and print whatever character fits with that. That's no bueno. So that's one. These are okay. That's okay. This is a uint 8. And a uint 8 has pentillion, billion, thousand. Okay, so the numbers are okay. Yeah, and you can only be 0 or positive, so the problem though is that this is a uint 8, so if you print age, because we aren't outputting this guy, so I don't think there's an issue with uint 8t, the 8-bit version of an int. And we're just extracting that guy to be age. And he's value initialized, so this feels okay. And then we print this. Seems okay. If age is greater or equal to 16, which we now have here, then we'll put yes, and there's a space here. Otherwise, that means that you must be less than 16, so we say no. I still only see this right now. I mean, this is only an issue if you're over 127. And this should be getting the... No, that's gotta be it. It's gotta be this. It's treating it here, so I think when it does this comparison, it's going to be... I think we need to static cast... Either use a different type or static cast this guy to be an integer. Or an int 16, technically. To compare, because I think... no, I think character output, because I'm guessing that one issue might be if we ran it and said 6, it might add 48 and say, oh, well, 54 is greater than, so yes, still, even though you're only 6. And that would be because it's doing the ASCII value. I know standard character output does that. I don't know if standard character input does. If it does, then that's one issue. So we need to either cast this guy here, static cast to int age, or change the type to uint 16 or int 16. What would be the third if I assume that's true? Boom, boom, or... And we're returning this. We're not returning from a function some boolean, so I think this is okay. Because we're saying if this, then this. If not, then this. The only options are greater than or equal to 16 or under 16. That's how math is. We're including these guys. Are we using anything that we don't have numbers for? We have character input and output. The only other thing we're using, C standard integer. That seems okay. I don't even know if you need that. Trying to get good at reading it so that I don't have to run it and see what's wrong. Just so I can get better at understanding code from looking at it. It's probably helpful. It's like writing something better the first time. And we use this first. IOStream should be last. So we're prompting the user. We're then initializing this, value initializing it. Oh! So this might be another thing. But it could be the same, because if we're extracting age in... Because if this was a number, this would be okay, but because this is like this, I think extracting age here, like if I put 53, it's gonna take it as a character, so it's definitely, it really feels like it's gonna say 101. It's gonna add 48 here. Because this is behaving like a character. Because the only integral type that's native to C++, not this guy, is a character. So it feels like this same result using unsigned in here is gonna fuck you up twice. So either you because age's type is set, so you'd either have to subtract 48 or change this guy to be an int. Feels like this fucks you up multiple times. This records, so this is going to be storing it like a character. So you might get funky results because you might be putting in 16, but it's only storing one character, so it might only be storing one. I feel like that's what it's gonna do. So even if you say 99, it's gonna store 9 maybe and then stop. But even if it worked, this thing behaves like a character, so it might be adding 48 too. And then here's the character. So far everything is involving the characters. Let me look away for a sec, and then reset. Oh, let's play an OC song.
Welcome to us. Click the
How are all these? Why are all these songs appearing? All in blue.
See you next time.
The issues I'm finding. It feels like int 8 fucks you twice because you might be entering a number that's more than one character. It feels like it's also behaving like a character, so it might be adding 48, so your number comparisons might be wrong. So it might be okay if you do 6 because it's only one character. Because it's not gonna if you enter 16 or something big, you could enter a billion, and it's not gonna take anything until you press enter and do that inline. So it might only be extracting the first character. Because this guy's behavior is dependent upon the variable. What he takes. So he might only take this. Yeah, because he's trying to fit something in, like, I'm holding a bunch of stuff, and then underneath is a little tiny hole in the ground. If I release, but there's only a tiny little bit of room in the ground, the rest is going to pile up. If he can only fit a uint 8, he's only going to put a uint 8. So he might only extract the first number. He might also be adding 48 because this is an 8int guy, or an 8-bit guy instead of 16. So it's going to think it's a character and treat it like a character. At least character output would. I'm guessing character input would. And then this is not a character. This is a string at this point. This is multiple characters. This is the inline character, but this is another one. Alright, I'm going to copy this and see what happens. So we're going to do 16, and it's going to say yes, but it's printing something else. So it's printing... Oh, okay, so it's printing this, so we know that's an issue. So 16 is okay. What if we say 15? 15 is also saying yes, and I'm guessing it's because of that. I'm curious, will it be okay if I said -2? Just say yes. What if I said -100? Well, actually, that won't matter. That's not gonna matter because it's wrapping around anyways. Okay. So one issue is definitely this uint, and it's adding. I want to debug this guy. So we're gonna do step into, we're watching all locals. So age gets value initialized to be 0, and then it gets, we'll just do 16. So it stores 49. 1? I don't know what that means. What is the 1? I'm not sure. Okay. So it's adding 33. Oh, maybe... Okay, that number's weird. Oh, that's why. So it is, I was right on both fronts. So not only is it adding, because it's thinking this is a character, I think I got all 3. Because it's thinking this is a character, it's adding 48. But because it's thinking it's a character, it's only storing the first thing, 1. 1 plus 48 is 49. So int is uint here, this character guy, or character, quasi-character thing, is fucking you up twice. It's messing up what you're extracting, and it's adding 48. It's using the ASCII value here, because why is it doing that? It's doing that, I think, because we're extracting. So if it's extracting a character, it takes the character's ASCII value, and it only takes a character, not the whole number. So if I did 50, it's not doing 50, it's doing 5. But it's not even doing 5, it's actually doing 53. So it's adding because it's extracting an ASCII value, and it's only doing 1 character, and this guy here has an extra period. So if we just swap this guy to be int, we would be, well, we'd have to change the type, right? Because otherwise we're just gonna keep extracting a character. I'm just gonna give it that. We're gonna keep extracting 1, and we're gonna keep adding unless we do this, I think. So if we say 16, we're okay. If we say 15, we're okay. I think those are the 3. That's all I'm seeing, dude. But so that gets the program to work. Now, how do I make it work better? Is there anything here about some design? This guy's obvious. This guy. Could I do anything different? The problem is we're extracting to his type. And we're extracting to a character's type. Is there a way that I can turn off the character behavior? I don't remember. There's bool alpha. I feel like there isn't, man. If I just do that. Wait, whoops, sorry. Well, wait, whatever. We can do int. That's fine too. Maybe 2. Well, I mean, I guess you want a uint. Oops. Cool. All right, the numbers work. It makes more sense to just do an int. Excuse me. Is there a way to customize character output? Character output part is okay, but the problem is we're storing him as a character. If age is... So what? Find the mistakes. Isn't that it? Find 3 issues. What are any issues? This is the right order. Prompting the user. We're then initializing a variable value, or then value initializing a variable for 0 to clear the garbage value. We then assign it via character input, the age, which is an integer now. We then say allowed to drive in a car, allowed to drive a car, allowed to drive in a car, allowed to drive a car in Texas. And then we say if the result is whatever, then we say yes. Otherwise, no. Dude, it feels like that's all. It really feels like that's everything. God, I don't want to find a solution, dude. Fuck. Fuck. I should have been more rigorous, man. 16. I mean, this feels okay, but we could, I mean, it would make more sense to say int age to drive, or legal driving, or legal Texas driving, legal Texas driving age, and then we assign it to be 16. Then here we say legal Texas driving age. Fuck, man, I knew it. Get rid of the magic numbers, bro. Fuck. Yeah, so it's 2 things. So 1, it's behaving as a character, so we're only extracting a little. And it's also adding that regular int. Yeah, and we don't need that because we were only using it for that 1. It's true. We're using a magic number. I mean, it's a rational reason, but because it's not 0 or 1, okay. And a const expression just so that we can use just for efficiency. Just so that the program can guaranteed swap this guy in. Boom. Swap him in using that good old constant propagation. Well, I mean, you could do double quoted, or you could tag it on somewhere else. No, or that. I mean, what are the primary differences between this and this? And then there's 2 more. Oh, God. The primary differences between standard string and string view. So string is an owner, whereas string view is a viewer. So string actually owns a piece of memory with some values in it that it can do things to and it uses. Whereas string view instead stores a view to another variable's value. So it doesn't actually own it. It can be assigned different values, but it doesn't affect those values at all. It relies on that thing because it's viewing it. So it's viewing another variable. So if that variable's value changes, if the viewed variable changes, then this value will be, or this variable will be invalidated. We won't know what will happen. It might be the same thing, especially if memory doesn't change. If the variable change over here doesn't use any more or less memory, we might be okay. If it uses more, we might be screwed because we're gonna be viewing a piece of the whole. But if it got smaller, we're gonna be viewing too much, and we're probably gonna get some garbage values. So we might be missing stuff. We might have extra stuff. It's undefined. It's ill-defined by the C++ language. Let's see. String views cannot be implicitly converted into strings or standard strings, whereas standard strings can be implicitly converted. Well, it's not implicitly converted. It's just that string view as a temporary value as a temporary variable will view the standard string variable, whereas the standard string variable will attempt to convert the value, and C++ will not allow you to do that. What can go wrong? Well, if you change what the standard string view is looking at, then it will invalidate the standard string view. You could return standard string view from a function, and if standard string view is viewing a local variable in that function that gets destroyed upon the function's completion, its ending curly brace, then you're going to be returning a view to a variable that doesn't exist, which will probably be undefined behavior, or at least you'll be looking at memory where the variable was before it was destroyed, so you'll probably get maybe what it was, or maybe nothing, maybe whatever is there now. Excuse me, which might be garbage values. Another is that you can't change anything using standard string view. So if there's a variable, if I got a picture of my buddy's car, I can't change it by writing on the picture. It's not like a pointer or dereference or something. That feels pretty exhaustive. True. It's also that's also the main thing, is that it's expensive. So copying a standard string is expensive, whereas string views aren't necessarily copied. You're just viewing whatever it was viewing. So one thing's viewing something, another thing view this, or so string view is viewing a string, another string view is set to equal to be it is assigned whatever's here, which means it's also looking at the same thing. So standard strings are expensive, so we use standard string views in order to look at the values without actually changing them. So one, standard string is modifiable, but it's expensive to initialize a copy. It's read only, so we can't do anything there. It's easy to initialize and copy. It can be dangerous when the string viewed is destroyed before the string view that is viewing it, because if you use the string view after whatever it's viewing has been destroyed, then you're left with values that you don't know, unless I guess you've explicitly cleared them afterwards, some sort of cleanup procedure maybe. Write a program that asks for the name and age of two people. Oh, Why can't age 1 in main be constant? It seems pretty easy because it isn't known at compile time, right? Assuming age 1 means if there's name 1, age 1, name 2, age 2. Well, none of these can, because none of the values are known at compile time. Not to mention const expression string doesn't even exist until C++ 20, so we'll just ignore that. The numbers are, but these aren't known yet because they haven't been extracted yet. So the name of 2 people. So we need output. We also need a string. I don't know if I need we'll do string view just in case. What would I use it for? Let me figure it out. Hold on. Let me find out what I need first. Oh, it's actually 11:30. It's time for game dev. So let me actually open that back up. These should all be done now. Please. Bop, bop, bop. Please. Okay. Continue question 4. Oops. Oh, whatever. It's fine. Okay. Well, we'll continue tomorrow. That's 3 hours, 20 minutes. Okay.